right, everybody, I think we're going to get started now. Looks like most people are here. The door is still open if people are coming in. We just closed the door because of the noise. So everybody wants to grab a slice or a quick drink and have a seat, we can get going. All right, let's just get started. So this is Eugene Webdevs Meetup. Thanks to everybody who's coming. Thanks to anybody and everybody who's watching on our new stream. We got a stream going on our YouTube channel. There's a link to it at eugenewebdevs.com. We're planning on streaming all of these. We've got a cool little GoPro here to do picture-in-picture with the slides, so it should be really good for watching the content later. Pretty excited that it works. So it was a lot of fun setting up. I want to start by thanking anybody and everybody who participated in the Technology Association of Oregon's Hack for a Cause the other week. Yeah, awesome. I know we've got some people here who participated in one. Some really cool stuff that was created. It's a real fun event. It'll come around again next year, I'm very sure. And I'm excited to see where some of these projects go and how they help the community. Next month, we're doing lightning talks. This is going to be 10 to 15 minutes on something new and shiny, basically. So we've got a couple of those, but we still have room for maybe one or two more. If anybody's interested, you can just hit me up after this, and we can talk about it. And after that, we don't have anything scheduled for the month after, but we're always looking for new talks. So anybody who has an idea or something that would be great for the web dev community, let me know. New thing I wanted to start doing was always mentioning the job pages. There's lots of jobs here, Eugene and Tech. Our page is idxbroker.com/careers. And we actually just redid it. Bishop launched that today, so it's all redone with all the shiny available openings and easy ways to contact us for a position here. We had a order fulfillment specialist, a software application engineer, and a tech support specialist position open here. I have a page on the GitHub repo for Eugene Web Devs that has links to other companies that are hiring, their hiring pages. And the newly created Eugene Tech Jobs page. So check all those out if you know anybody who's looking for a job, positions that are open. So yeah, I think that, again, thanks for coming, and let's all give it up for Derek, who's going to be talking about AWS Serverless.
Test. Need a little more volume, maybe? Test. Better? Hear me? Okay. We'll assume that's a yes. Okay. So thank you, Antonio, and thanks to Tim and Antonio for getting this great new streaming system set up. I was approached actually by Max close to a year ago, maybe, to give a talk about AWS, and I hesitated because it's way too broad of a topic. In the 20 to 30 minutes I have to stand up here, I could basically just list AWS services and then go have pizza. So I decided to narrow my focus a little bit, and what I decided on was to go with what's pretty much the hottest thing in the cloud right now, which is serverless technology. Even that subset is kind of hard to cover in this period of time, so I do skim. I think there's probably room for more talks on the subject for sure. Where's the power button on this one? There we go. There we go. All right. So who am I? If you were here to hear a talk from a former Bulls point guard, you're probably a little disappointed. I get that confusion a lot. We are fairly easy to tell apart. We do both look good in red, but he's 9 years younger. He spells his name the English way. Come on. There we go. And my free throw percentage is garbage compared to his. Who I actually am is the VP of Engineering here at IDX, so I oversee all things with software design and development as well as hardware architecture. I was the second paid employee here at IDX behind our co-founder, Jeff Cast. Through IDX, I've been using AWS since 2006. We started with S3 back in the days before there were SDKs. I have AWS certifications as a developer associate and a systems architect associate. I consider myself a programmer since about '99, although I dabbled in BASIC as early as the '80s. And I currently hold the IDX record for burger time, which is a nice safe record because that arcade machine has been broken for years. So that's who I am. What am I talking about? As I said, serverless technology. But if you ask 10 people what serverless means, you'll get 10 different answers. So I looked around and listened to some podcasts, what other people call serverless. The narrowest definition I heard was that it's an op-free environment. So all you have to worry about is code. I'm going to break it to you, there's no such thing as an ops-free environment. And this is no different in that respect. The widest definition I heard was that it's any server you can't log into. But by that definition, Amazon's RDS service, which is MySQL, Postgres, Oracle, that would also be considered serverless, which it most certainly is not. So my definition that I came up with, middle of the road, was this: serverless is when you don't have to worry about RAM, CPU, I/O, networking. That's not to say you can't, but usually the defaults are good enough, the controls are minimal, you don't have to, the defaults work for you. So if this is your average monolithic application, and say this is a containerized application, Docker or Rocket, then this would be serverless. Just a few knobs and buttons. So I want to start with a quick overview of what I see as the serverless resources that AWS provides. This is not an exhaustive list. I've almost given up on trying to keep up on all AWS releases, but I may have missed some. Some, like Lambda on the next slide, we'll go into in fairly graphic detail. Others we'll kind of skip for time. So when people are talking about serverless, they're probably talking about Lambda. Everyone has their function as a service product, but Lambda's kind of where it's at. I say function as a service in the same breath that you might say software as a service, platform as a service, infrastructure as a service. It is just a function living on a server somewhere. You upload your code, you define how much RAM it needs. The lowest is 128 megabytes. Optionally, you can put it in your VPC, and then you just set a means of activating it. Amazon does the work of finding server space, provisioning, making sure it's always triggered at the right time, and dealing with any software or hardware failures. Lambda currently supports 4 languages in Node.js, Python, C#, and Java. I have heard that Golang is on the way. Keep our fingers crossed for that one. You pay for every 100 milliseconds that your code runs, and that's rounded up. Just FYI. So the faster your code runs, the less you pay. In other words, you need to pay attention to how efficient your functions are, because you pay less, the better they are. My Lambda experience is entirely in Node, so I know that you can include npm and yarn packages. I know you can also do pip packages in Python, so long as the package is natively written in Python. And I assume the same is true for C# and Java. As an overview, here's what the console looks when you go to create a function. There are nearly 90 blueprints that you can choose from to get you started. Most of them are repeated per language, so it's probably closer to 25. But the most common use cases for Lambda are represented for every language. Then you set up a trigger. This is a skippable step because you can define your triggers multiple places throughout the console. Here is what the selection looks like when you click on that little box you can't really see in the slide. Then you get into actual code. Here's the configuration. There we I captured this screenshot with the runtime selection box highlighted so you could see one particular possibility that you can run, which is called Lambda at Edge. This was debuted last December at reInvent, and it's currently only available for Node 4.3, so that's important to know. I believe 4.3 covers some of ES6, but none of ES7. This is for very specific use cases where latency is important to the degree that the speed of light matters. With Lambda at Edge, your code lives and runs on Microsoft's CDN edge locations. So they have nearly 60 edge locations throughout the world. And your code actually lives in those distributed areas so that it is as close to your users as possible. This is the console once you have an existing function in there. This is a simple function I implemented recently based on one of Amazon's blueprints, which translates Apache log format into JSON. It also does some sanitizing and sanity checks and that sort of thing. It's important to note here, and you can see the yellow box, this inline editor will only work on your main function file, in this case index.js. The yellow box is telling me that at some point, well, in the previous version, I uploaded a npm module, and if I edit it in the code editor here, it'll just go away. So here is what it looks like when you go to upload from S3, or you can also just upload from zip. These are what you need to do if you have a node modules directory and anything in there. Let's quickly cover Lambda events because they are broad and getting added to constantly. CloudWatch schedule events were added, I believe, about 18 months ago. They effectively let the clock be the trigger, so it's like a cron job at that point. Here at IDX, we have a Lambda function that creates and prunes our database snapshots once a day based on one of these CloudWatch scheduled events. Kinesis Firehose, which I'll describe more later, can send each payload that goes through it through a Lambda function for transformation before sending it on to an endpoint. And then there are the true event triggers. This isn't all of them, just kind of a hand-picked list. Basically, it's when X happens, send it through Y function. So if a CloudWatch alarm goes off, for example, you can have a Lambda function go and take a EC2 snapshot, console snapshot, so you can see what's actually on the screen of your EC2 instance. When an object is added to S3, you can send it to a function. When you have a RDS lifecycle event happen, like replication failure, you can trigger a Lambda function on that. When an insert happens on either Aurora or DynamoDB, you can send that payload of data through to Lambda to do something else. So that's the basic idea behind events. Your Lambda event? If you put it behind a API gateway, then yes, although not directly. I'll get to that. In fact, that's the next bullet point. Big dog on this list is the API gateway. With that, you can send all your API requests to Lambda, or any other public endpoint for that matter. So with API gateway, which I'll describe in a little more detail later, Lambda can be your API. It can also be a transformation layer on top of your API, or if you have a static website, you can also route your AJAX functions through API gateway to Lambda and basically have that be your data layer. One thing not on this list, because Amazon considers it its own product, there we go, is step functions, which were also released back in December. If you've ever worked with the JavaScript state machine, you'll be familiar with this concept. Here you can design a data workflow in a graphical environment. You can also set things up as, I believe JSON, might be YAML, if you don't want to use a GUI. And it's the basic idea of a step machine. You have a function, call next. There can be logic in there to fork out your process, but your data just falls through a succession of functions to get to a final state. Oops. There we go. Jeff Barr tweeted this yesterday, I believe. A clever function somebody blogged about. I believe there's 39 possible configurations when you set up a Lambda function. And this is a little bit simplified view, but this person basically set it up so that he can send his data through to a step function. The step function will decide how much RAM it needs, what the configuration is, and then automatically route the data through the function that will cost the least. So that's Lambda in a nutshell. I think an entire talk could easily be done about Lambda. But we have other fish to fry. DynamoDB is Amazon's native NoSQL database engine, which was built on the foundation of S3. Like all NoSQL, it's a super fast key value store. Dynamo also has global secondary indexes and range keys that make it second to none when it comes to time series data, which is why AWS has been able to get such a running start when it comes to Internet of Things, because time series data is the bread and butter of IoT. SimpleDB was Amazon's first stab at NoSQL. I also wouldn't be surprised if it's the first product Amazon ends up sunsetting. It might be lack of imagination on my part, but I wasn't able to think of any scenario where SimpleDB was preferable to DynamoDB unless like every single penny matters. As I said, Dynamo is based on S3, so you should also consider S3 to be a NoSQL engine. It's far slower than Dynamo, but you can do object scans, you can set lifecycle rules, there's inherent object versioning, optional encryption at rest, and 16 layers of redundancy. So it's a great and fairly cheap choice when latency isn't a big issue. I also wanted... yeah, especially if you can set up a lifecycle rule to send them to Glacier if you don't need to access them frequently, because then the price decreases by 6/7. So, I also wanted to mention Amazon Athena, another product introduced in December. This allows you to run ODBC compliant SQL queries against your JSON and CSV objects while they're sitting in S3. You don't have to do any database ingestion. Just you point your database at a bucket and it's good to go. Also released, I believe, yesterday or maybe the day before was Redshift Spectrum, which is kind of an interesting product. It is Redshift, so it's a warehousing tool, columnar database, but it can also query S3 directly, again, without ingestion. So it could be a potential good use case for like a warm-cold analytics situation where you keep your warm data in Redshift, your cold data in S3, and you can use Spectrum to query the entire thing. I also want to make a note about search. Amazon has two reverse index services in Cloud Search and Elasticsearch service. These are definitely not serverless products, but coupled with DynamoDB and ESS or CS as your search layer, you can make some pretty powerful applications. And Amazon, it's still managed, those are still both managed services on Amazon, so the ops load is very low on your part. Okay, so now you've got your code and you've got the data to drive it. How do you get in front of people? API Gateway is a full-featured gateway featuring authentication, rate limiting, caching, lifecycle management, automatic SDK generation for I think 4 languages, and monitoring, all for $3.50 per million calls. You can point at any public endpoint, including Lambda functions or step functions or whatever you already have running. Cognito is really more of an API style product than a serverless, but it is a potential authentication layer for API Gateway, or it can stand on its own and be an AWS native alternative to something like OAuth. You get the power of IAM for your own application. Many people surprisingly don't know that S3 has the ability to host static sites. We have a couple static sites. I believe they each cost us 4 cents a month on S3. They're truly static, but you could use Lambda to publish pub sub events to a static site, or I mentioned running AJAX through API gateway using Lambda. So you could have a very dynamic site without having any server in place to maintain it all. It all just lives on S3. Put all that behind CloudFront, which is Amazon's content delivery network for extra speed, resiliency, and scalability. I mentioned previously that CloudFront has almost 60 edge locations. It's 58 as of yesterday. And that's all around the world. So you can really drive latency down by getting your code as close to your client as possible. Once your site is behind CloudFront, then you also gain access to Amazon's web application firewall, which itself can tie into Lambda. You can kind of see how Lambda is the heart of everything here. AWS has a lot of examples on their GitHub page for things you can do with WAF and the config files and code to run it. One great example is they actually have a CloudFormation template, which is one of their provisioning systems, to spawn a system of Lambda functions and CloudWatch log monitors that will automatically block any non-human traffic to your site. And then lastly in this section, I wanted to mention Route 53. This is a full-featured DNS solution that costs the average user about 50 cents a month. It has a number of AWS-specific features that allow you to route traffic to S3, to DHCP allocated load balancer, and API gateways very easily. And like everything else in AWS, there's an API and many SDKs, so you can make your changes procedurally. You don't have to go into a UI all the time. Messaging is vital to distributed or microservice applications. Additionally, the ability to communicate with your clients is a must for most client-facing applications. So what's available in AWS in this respect from a serverless point of view? Simple notification service is the backbone of most event services in AWS, has been for many years. When something happens, you can send it to SNS. SNS can send an email. SNS can send text messages. You can also send its payload to HTTP endpoint. And that endpoint can be Lambda behind API gateway. Simple email service is all about email. It's designed to fight spammers and therefore be friendly to email service providers. Because it's focused on not being a tool for spammers, there is a ramp-up process. When you sign up, you can only send a certain number of messages per hour, and then you can ramp up. The longer your account's been in good standing, from my understanding, the faster support will answer your request for more throughput. And it's a really cheap service, but you do have to handle things like bounce handling and non-deliverables. And if you do business in Canada, you got to be CASL compliant. In the US, there's CAN spam. So that's all on you, but it is very cheap. SQS, Simple Queue Service, is gradually becoming more and more feature complete. As an example, they, in the last couple months, added first in, first out queues. Used to be first in, probably first out. It can also support very large payloads, which is not normal for queue services. Queue services, usually your max payload is measured in kilobytes, but SQS will automatically push larger payloads to S3 and then fetch them. That obviously slows things down, but it is a nice feature. Kinesis is a little bit of an odd duck because it's actually 3 products, and if you're looking through their service guide or IAM setups or anything like that, they're all treated like separate products, but you have to go to the same console page to get to them, so a little weird. Kinesis Streams allows for analysis of your streaming data while it's in the pipe using SQL statements. So between point A and point B, you have access to your data. Firehose is a buffering delivery system that allows you to transform your data en route using Lambda. Our logs, for example, we stream from 20 plus origins through Firehose. Everything gets turned into JSON by Lambda and then sent off to a single origin, or a single endpoint rather. Firehose buffers, and there's also a Kinesis agent that lives on your box and just monitors files for changes and automatically pushes them through Kinesis. Yep. It's very similar to Logstash, if anybody is familiar with elk stacks. Then Kinesis Analytics is fairly new. I don't have any experience with it. It basically allows you to build a function on top of your data as it's streaming across, or an application, they say. I haven't gotten to play with it yet. It's on my list. So Kinesis can be a message broker, or it can be a real-time analyzer, or it can just be a buffering transport service. It fills a lot of niches. There are also a trio of AI products, all again released last December, that fit into this serverless mode. Lex, as in Alexa, is kind of a chatbot as a service product. It allows you to build conversational interfaces using text or voice. You can build your decision trees graphically or through config files, and it offers some fuzzy matching logic. So you can really build something that seems very conversational. Polly is a lifelike text-to-speech product, again, I believe spawned out of Alexa, that supports something like 50 different voices and 24 languages for any sort of text-to-speech type needs. And then Recognition, no, that's not a typo, is image analysis AI service, and the one I came away from reInvent last year being most excited about. People focus on the fact that Recognition can do facial recognition, and it does it very well, surprising accuracy. I think Google's product is perhaps a little bit better, but you can only use Google's facial recognition from inside cloud compute, so it's a little limited in that respect. But this also has environment detection. So if we look at this picture, we can send that to Recognition, and it will send us back a JSON payload with everything it sees and a confidence rating as to how sure it is that it is what it thinks it is. So we basically get back a piece of JSON that says, I'm 99% sure this is a man, I'm 98% sure he's smiling and wearing a coat, 97% sure there's a dog, 95% sure it's a golden retriever, and 95% sure they're standing on a beach. It will also give you coordinates for everything it sees. So within the image, you can highlight or hide anything from the list that it comes back. So if you're ever wondering how to do automatic license plate or face blurring, Recognition is a good way to do it. And all this, there's no management for these three services. They're kind of one step above just an API. The downside is the cost. Lex isn't too bad if you're doing text. I want to say it's $1 per 1,000, $4 if you're doing voice, $4 per 1,000 also if you're sending images through Recognition. We did some math a couple months ago, and we decided it was going to be multiple millions of dollars to process all the photos we see in a year through the system. So we can't have it, but I want it. I'm hoping as they get up to scale, price will come down. Fairly new service. Some considerations. Costs can really skyrocket quickly with this sort of thing, because basically, even if you haven't changed anything, your traffic patterns can affect your cost. So be sure and turn on your billing alarms and keep an eye on things. And keep an eye on how long Lambda functions take to run. You need to be on top of the newest tools because this is a very new environment, and a lot of the tools aren't there. Testing is slightly hampered. Functional tests aren't bad, but if you want to do full application testing, it's a nightmare. There's not yet a publicly available APM for Lambda, although Amazon X-Ray did open up a beta on Monday, I believe, to give you more insight into how all your interconnections are working within your application. It's worth repeating that this is not a no-ops environment. A lot of people will tell you it is. It is not. There are always going to be some maintenance that has to go on, some growing pains. But it's nothing like trying to maintain your own server or even your own EC2 instance. Complexity can get complicated very fast in terms spaghetti type codes. It is very similar to microservices in that respect. You got to keep constant eye on it, which is a good lead into the fact that most microservice patterns are going to work really well with serverless. They're cousins in that respect, so don't overlook patterns when you're designing your serverless app. Also, this is one thing that isn't documented very well. You'll see it in one or two places buried down at the bottom of a page, but the more RAM you dial up for your Lambda function, the more CPU, I/O, and network throughput you get. So if your function isn't running as fast as you want it to run, even if you aren't memory bound, try turning the memory up a notch. And then to wrap up, I just thought I'd go over a few common use cases for serverless. I have heard that image resizing is the genesis of Lambda. It is the problem they were trying to solve when they came up with it. So this is a very common use case. If you search GitHub, there are thousands of code examples on how to do this. Basically, the idea is that you put your image into S3, and then you have a new object event fire every time an image goes into that bucket. It sends that image to Lambda, and in the language of your choice, resizes it however you choose. And again, you can have your packages like ImageMagick and stuff like that in order to do the resizing. This image, stock image I got, kind of shows it going directly to the user's device after that. Generally, Lambda is fast enough to do this, but I'm paranoid. I don't like to. The process I'm currently in the kind of last step before implementation phase on is image goes into one bucket, Lambda resizes it, puts it into a separate bucket so that we don't trigger those new object creation routines again, and then sends off a JSON payload to SQS to queue for my app to ingest later all the image sizes and full list of images that I came up with. Logs, also very, very common. We just implemented this within the last couple weeks. So we have 26 EC2 instances, I believe, all shipping logs through Kinesis Firehose. Every single Apache log entry goes through Lambda, turns it into a common JSON format, and then we go into two directions. We have Amazon Elasticsearch service, which is for hot analysis. We've been collecting data since the 4th, but my plan is to leave about 6 weeks worth of data in Elasticsearch. See, we're about 150 hits per second on average, so we generate a fair number of logs. It's a lot for Elasticsearch to constantly index. And then we also send everything through S3 to our data lake, which we can then query with Athena. And Bishop was awesome enough to get a beta of Tableau's new Athena connector. So we can deliver those cold logs, if you will, to business, and they can just have their Tableau dashboard like everybody wants. And then one last good use case that's also very common is IoT. This is Amazon graphic that I stole, which is why it's a little fuzzy. But the thing with IoT is that your just constantly generating data, and if you're successful, you're potentially generating it from millions of separate sources. So if you have a server go down, that can kind of be it. Like all those services trying to gracefully connect to your system, things can go haywire really fast. So serverless through Kinesis, one form of Kinesis or another, and Lambda and Redshift or Dynamo, these things are much more fault tolerant because Amazon will just pick up where you left off. It's really nice that way. We don't do IoT, but I've heard a number of people talk about this as kind of being a lifesaver of that industry just because it's so much data and it never stops. So with that, I'm going to take questions anyone has. Going once. Yeah, you will see a good number of Google results debating that. I think for most people, yes. There are probably some power users that Kafka still has the power that they need and Kinesis doesn't. But in general, yeah, I think it's a... Oh, sorry. The question was if Kinesis could be a replacement for Kafka. And yeah, like I say, for most people, you aren't handling so much data that you're overloading Kinesis. So, and Kinesis does scale. There are occasionally, if anyone's worked with elastic load balancing, you might be familiar with surge queues, whereby all of a sudden Google will come through or somebody and it'll overwhelm the number of servers that Amazon has provisioned in your load balancer, and it'll have to queue things up while it provisions more servers. You can get some of that with Kinesis as well. Kinesis does maintain your timestamps, though it's good to note that the timestamp it preserves is the timestamp it first saw it. If you're streaming out of logs, it's not the timestamp of the log itself. Can be. It can be a little bit of a nightmare. There are a number of GitHub projects that are getting pretty mature at this point, and then Amazon released in February, I believe, a product called SAM, and I don't remember exactly what that acronym stands for, but it is a provisioning system specifically for Lambda. Anyone else? SNS, Simple Notification Service. Yeah, you can use it for email notifications. You tend to get, it wants to format the message for you, so it's good if you're getting an alert email. It's not so good if you're sending things out to your consumer. Yeah, I would use, if you're going to send anything to an end user, people do use SNS for text messaging, but if you're going to do emails, I would recommend the Simple Email Service, SES. All right, thank you, everybody.
So thanks, Derek. Thanks, everybody, for coming. Just let everybody know, we're free to hang out, free to have a little more pizza and discuss and talk and bother Derek with all the questions you want.
We don't want leftovers. Please
we don't want leftovers, so please eat plenty of pizza. If anybody else is interested later, I'm going to level up to play the new Super Mario Kart game. It's going to be awesome. So thanks again for coming, everybody. Thanks to IDX for the space. Thanks to Derek again. Give it up one more time for him, everybody. And thanks to, I think, all 4 people who watched this at home, however many that was. I'm just kidding. All right, thank you.